Okay, so this paper is June 2021 for two. The first question, um, this is the mechanics paper. A particle of mass 0.6 kgs is projected with a speed of 4 down a line of greatest slope. Okay, so there's a slope 10 degrees and mass is 0.6. Is projected with a speed of 4 and it's a smooth plane. Use an energy method to find the speed of the particle after it has moved. Let's assume that it goes down to the bottom of the plane, which is 15 meters, and I want to find V. Now, since there are no external forces acting on the particle, I can say that the change in Ke should be the same as the change in P. So half m V square minus U square m G. The change in height would be through a right triangle. If this is 15, then this must be 15 sine 10. So I get 15 sine 10. Okay. So let's calculate all of this. I think this cancels out with that. So that makes the question a little easier. I get V square minus 16 equals to 20 into 15 sine 10. V square equals to 300 sine 10 plus 16 and then a root. So 300 sine 10 8.25. Let's check if that answer is correct. Let me open up the marking scheme. The paper is so that's 8.25 meter per second. The next question is about coplanar forces. It says coplanar forces of 34, 30, and 26 act at a point in the directions shown, given that sine alpha is equals to 5 over 13. So my first task should be to calculate cos alpha because that is also something that I'm going to use. That is going to be 12 over 13. I use my calculator to find alpha and then put cos of alpha on the calculator only. Similarly, I have sine of theta, which is 8 over 17. Let's quickly calculate cos of theta is 15 over 70. Okay. Find the magnitude and direction of the resultant of the three forces. So there must be a vertical resultant. For the vertical resultant, I will have to resolve the forces vertically. I have 34 cos theta. And downwards, I have 30 or 26 cos alpha. I think the 34 cos theta force is larger. So the vertical resultant comes out as 34 into 15 divided by 17 minus 26 into 12 divided by 6. I get 6. Then let's talk about the horizontal resultant. There are two forces to the left-hand side, 34 sine theta and 26 sine alpha. So 30 minus the right forces minus the left forces. I get 4. So there's a horizontal resultant that looks like this, and there's a vertical resultant that looks like this. So the overall resultant must go like that, and that is using the Pythagoras theorem that r square should equal 6 square plus 4 square. I get root of 36 plus 16 is 52. So r equals to root of 52, which is 2 root 13. And for the angle, I can do tan inverse of 6 over 4. So the resultant has a magnitude of 2 root 13 newtons and acts at an angle of 56.3 degrees anticlockwise from the positive x-axis. It's important to describe the direction appropriately. Okay, let's see if our answer is correct. Okay, the answers are correct. This says a ring of mass 0.3 kgs is threaded on a rod. Let's bring this a little forward. So there's a ring. The coefficient of friction between the ring and the rod is 0.8. A force of magnitude 8 newtons acts on the ring at an angle of 10 degrees. Above the horizontal and the vertical plane, find the time taken for the ring to move from rest, 0.6. So what I'm going to need is I'm going to need the acceleration. So I'm going to draw the forces first. There's R, there's the mass, then there's this 8 Newton force, and then there's the friction. If I'm pulling it to the right, the friction must be acting to the left. So let's try to first find out these forces for the value for R is R plus 8 sine 10 equals to 3. The ring must be vertically in equilibrium. It must be moving horizontally, but vertically it's in equilibrium. So I get 3 minus 8 sine 10. I get 1.6108. Okay. In order to find frictional force, I multiply this with 0.8. 1.28864. Find the time taken for the ring to move from rest. So I have the frictional force and I have the pulling force, which is 8 cos 10. So what I can do is I can find the acceleration using F equals to ma. F is 8 cos 10 minus 1.28864 equals to ma. divided by 0.3. I seem to have made a mistake somewhere. Let me check it. I just want to make sure that I'm doing this correctly. No, the acceleration is pretty large, so that's fine. But 21.966 is the acceleration. Okay, so 21.966 is the acceleration. It started from rest, accelerated at 21.966. I'm asking you to find the time, and I've given you the distance. So you use s equals to ut plus half at square. ut s is 6.6 of a and t squared. So t squared is 0.6 into 2 divided by 21.966. So t is therefore equals to 0.234, if I'm correct. 0.234. That's the correct answer. Okay, that's the entire question. Moving on. It says a particle of mass 12 kg is stationary on a rough plane inclined at 25 degrees to the horizontal. P acts at an angle of 8 degrees above the horizontal, above a line of greatest slope. This is P. This force is used to keep the particle in equilibrium. The coefficient of friction between the plane and the particle is 0.3. There is definitely gravity. Let me just draw that to 120. So I get 120 cos 25 and 120 sine 25. Okay, find the greatest possible value of P. If I want the greatest possible value of P, what should be happening is that the friction should be facing the other way in order to maximize P. What I'm assuming is that I'm trying to drive this up the plane so that it has to overcome friction and the gravity. So I get P cos 8, P sine 8. I have the normal reaction, R, and I have frictional force, which is 0.3 into R. So I have two unknowns, which is why the question is 6 points. So I'm going to try to solve for those two unknowns. So I'm going to say that R plus P sine 8 equals to 120 cos 25. And 0.3 R, which is frictional force, plus 120 sine 25 equals to P cos 8. So I can use a substitution for R or P, that's up to me. I can also just do them simultaneously if I want. I think that's going to be easier if I do that. I can just bring this to this side and, or rather use a substitution. Let's use a substitution. So using a substitution, 120 cos 25 minus P sine 8. Substituting here, that gives me 0.3, 120 cos 25 32.627. Speed. So gathering the P's on one side, I get 32.627 plus 120 sine 25. Cos 8 plus 0.0418 gives me 1.0321p. So 32.627 plus 120 sine 25 divided by 1.0321. 80.7. So that's the correct answer. It's correct. I have a rounding of error. It says from allow P8 less than or equals to 80.8. I have a small bit of rounding of error because I've done a lot of calculations. I could have done this directly and could have avoided that calculation error. I actually get 749 is rather than 50.7. Okay. Question number 5. A car of mass 12 kg, 50 kgs is pulling a caravan of mass 800 kgs along a straight horizontal road. The resistance to the motion of the car and the caravan are 440 and 280 respectively. So 440 and 280 respectively. The car and the caravan are connected by a light rigid tow bar. The car and caravan move along a straight horizontal road at a constant speed of 30, which means that the acceleration should be 0. Calculate in kilowatts the power developed by the engine of the car. So power in this case would be force into velocity. So I will try to figure out how to find the force in this case. I'm going to say that there's a driving force, let's call that D. There's a tension pulling it backwards, and there's a tension pulling it forward, and there is nothing else pulling it forward. So can I say that if I look at just the trailer, T should equal 280. Then the driving force should equal 440 plus 280. Because there's constant speed, the left forces must be equal to the right forces. So I get 720. So the power is therefore 720 into 30. 21600 watts. So I'm going to say that 21.6 kilowatts. Given that this power is suddenly decreased by 8 kilowatts, okay, so new power is 13.6 watts. Find the instantaneous deceleration of the car and caravan and the tension in the tow bar. Okay, so let me draw the diagram again. Just want to see one thing. Okay. So the speed remains constant because that is part A and this is part 2 of part A, which means that the speed has to remain constant. So the new driving force will be 13,600 divided by 30. So there's a driving force here, there's T here, there's T here, there's 280, and then there's 440. So I'm going to say that the new driving force is 13,600 divided by 30, which is 1360 divided by 3. So I'm going to keep it that way. That's the new driving force. So I'm going to say that D, which is 1360 over 3 minus T minus 440 is equals to 1258, and T minus 280 equals to 800A. I should get a negative answer out of this for acceleration. If I'm doing this correctly, I get 1360 over 3 minus 440 minus 280. I get minus 800 over 3 equals to 20508. So divided by 2050, I get minus 0.13 as the deceleration. Let's check if that's the correct answer. Yes, that's the correct answer. For that, for the value of t, you can simply do 176. Okay. The car and caravan now travel along a part of the road inclined at this. So there's an angle to the horizontal. The car and caravan travel up the line at a constant speed with the engine of the car working at 28 kilowatts. There's the driving force. Since the question says right at the start that the resistances the resistances remain the same, that is 440 and 280. What has changed is now there is a component for gravity as well. So 800, so I get 800 sine theta, and sine theta is basically 0.06. Not 800, but 8,000. 12,500 sine theta. It says a car and caravan travel up the incline at constant speed, which means that the acceleration is again 0. So what I can do is, again, I can equate the left forces equals to the right forces. For the caravan, I'm going to say that T should equal 280 plus 800 sine theta. And then D should equal 440 plus T plus 12,500 sine theta. In this case, D would now be 28,000 divided by V. I'll follow the value for T, which is 280 plus 800 into 0.06. I have 328. So 440 plus 328 plus 1250 into 12,500 into 0.06. 440 plus 328 plus 12,500 into 0.06. And V comes out to be 18.4 meter per second. This is 15.4. Let me check my calculations again. I think I made a mistake here. That should be 760. Silly mistake. I'm getting the correct answer, which is 14.4. It says find the increase in the potential energy of the caravan in 1 minute. So it's traveling for 1 minute, which is 60 seconds. It's traveling at a constant speed of 14.4. Then can I say that the distance covered is 14.4 into 60, which is 864 meters? If it's traveling 864 meters up and the incline of the plane is this theta, this should be 864 sine theta, which is the increase in height, 864 into 0.06. That gives me 51.84. So I'm going to say that P increases by mg 414720. I have a small rounding off error because this was supposed to be 14.359. So if I change those numbers, it's very important in the M1 exam to make sure that you take the appropriate numbers from the previous part because rounding off errors can lead you to the wrong answer. This gives me 413,536, which is 414,000 rounded off. Okay, this is question number 6. It says a particle is projected vertically upwards from level ground with an initial speed of 30. At the same instant, particle B is released from rest vertically above A. The mass of one of the particles is twice the mass of the other particle. During the subsequent motion, A and B collide and coalesce to form particle C. Find the difference between the two possible times at which C hits the ground. Okay, so that is an interesting question. Let's assume that this mass is x and this is 2x. In the other case, there's going to be two cases. Since it says two possible values, I'm going to say that there's another case running simultaneously. And that case should be this. Okay, since it's a question on momentum, we're going to use the formula for momentum. Momentum says that we will first have to find out at what height they meet and what speeds they're meeting at, and then only we'll be able to decide how to move forward. Okay, so this is a question merged with kinematics. But I'm going to say that this acceleration is minus 10, this acceleration is 10. If this travels a distance of, let's say, s, this will travel a distance of 15 minus s, and the time for both will be same. So it's a long question from here. I'm going to start solving it, and I'm going to say that s equals to ut plus half at squared equals to 15 minus s ut plus half at squared. Okay, so I get 30t minus 5t squared. Okay, 30t minus 5t squared, I substituted here. I get t equals to 0.5. So they're meeting after 0.5. Let's find out what their speeds would be. Particle, this is particle A, this is particle B, this is particle A, this is particle B. So particle A's speed before impact is V equals to U plus A and T. So I get 25. Particles B's speed before impact. So I get, so regardless of their mass, this would be the same for both. U plus A T 5. Okay. So in case number one, where the mass of A is x and the mass of B is 2x, I'm going to say that momentum before equals to momentum after. Momentum before would be 25 into x plus minus 5 into 2x. And the combined momentum would be 3x into v. So I get what the difference between the two possible time at which c hits the ground. Okay. So I get 25x minus 10x equals to 3xv. So I get 15x equals to 3xv. So in this case, what happens is the particles coalesce and c moves upwards. That tells me that c is now moving upwards. Case number 2 is 25 into 2x minus 5 I just want to check if I have the speed of B correct. Yes, I have that correct. Oops. Okay, let's check this one. 5 into x and 3xp. So I get 45x equals to 3x. So in this case, again, particle C is going to move upwards, but this time at the speed of 15. Okay, C moves upwards. What will happen is C has find the difference between the two possible times at which C hits the ground. Okay, so what is going to happen is C is already at a certain height. I've not found that her certain height. What I should do here is find that certain height, and that certain height is 30 into 0.5 minus 5.5 squared. I get 13.75. So what will happen is C is going to move upwards. It is starting off with a velocity of 5. It has an acceleration of -10. It's going to reach its maximum height. I want to find out the time. So to reach its maximum height, let's find out the time. And in this case, U is 15, A is -10, V is 0. Then the particle has to come down as well. I must find out how much distance it has traveled up. So V square equals to U square plus 2AS. I would also have done this together by saying that I would want the displacement to be a certain number, but let's calculate. So 0, 5 squared, 2 times minus 10 times S. So that gives me 25 over 20, 1.25. 0 squared, 25, 15 squared. So in this case, 15 squared divided by 20, that gives me 11.25. So then coming down, I have a total distance of 13.75 plus 1.25. That gives me 15. 13.75 plus 11.25. That gives me 25. I have an acceleration of 10. I'm coming down. I have a starting speed of 0, and I need to figure out t. So S equals to ut plus half at squared. So 15 divided by 5 gives me 3. So t is equals to root of 3. And in this case, 25 equals to 0 plus half n t squared. So t equals to root of 5. Okay, so total time is then 0.5 plus another 0.5 plus root of 3. Here the time is 0.5 and then 1.5 and then root of 5. So the difference between the two times is 0.5, and root 3 gives me this 2.732, 0.5 plus 1.5 plus root of 5, 4.23. So the difference between the two times is 236 minus 2.732, 1.504. Yes, that's the correct answer. Long question. Question number 7. It is a particle moving in a straight line from rest at point O comes to rest 16 seconds later. So final speed is 0. At time t seconds after leaving O, the acceleration is given by this. There is no sudden change in velocity at any instant. Find the value of t when the velocity of p is 55. Find the values of t when the velocity of p is 55. So I would need the function for vt. So I'm going to integrate. Okay. So I get v equals to 60 plus 2t squared. So if I want to find out the values of p when, let's find out what the velocity is. The velocity at 2 is basically, since this is accelerating and never decreasing, I can say that the velocity is also always accelerating between 0 and 2. So I have a velocity of 20 so far. So what I'm going to do is I'm going to integrate the next one, which has a constant acceleration. I'm going to say that I get 14t plus c. In this case, when I plug in 20, time is already 2. That gives me the value for c. So I have my function 14t minus 8. In order to find what speed I've reached so far, since I'm still accelerating, let's find out 14 into 4 minus 8. I've so far reached a speed of 48, which means that I'm going to reach in the next stage a speed of 55. So I'm going to integrate again. I have 16t minus 2t squared divided by 2 plus c. So in order to find the value for c again, what I'm going to do is 48, 16 into 4 minus 4 squared plus c. I get c as 0. So my function is therefore v equals to 16t minus t squared. Now at this some point during this period, I would have reached a speed of 55. It's a long period. So I'm going to say that 15 equals to 16 minus t squared. I bring everything on one side and solve. I get 11 and I get 5. These are the two values of t when the velocity of p is 55. Then it says complete the sketch of the velocity time diagram. Okay, that's simple. I have all the functions that I need. The first one is actually from 2 to 4. So this one is drawn. The linear function is drawn, 14t minus 8. I need to draw this one. So I need to reach a speed of 20 and I have a quadratic function. So I'm going to reach like that. This is the speed of 20. This is the speed of 48. And then I have a quadratic function that is 16t minus t squared. So this goes like that. It should reach a maximum point What maximum point will it reach? Let's just find out by differentiating, equating it to zero. When does it reach its maximum velocity? I'm going to say that it reaches by equating this to zero, I get t equals to 8. So it reaches its maximum point at 8. I will say that this is 6, this is 8, this is 10, this is 12, this is 14, and that is 16. So at 8, it reaches its maximum point. Let's find out what the velocity at 8 would have been. 16 into 8, 16 into 8 minus 64. So 64. So I reached a velocity of 64, let's say here, at 8. This function goes something like this. Okay, I think that's what the graph should look like. I think that's correct. Then it says find the distance traveled. I think that's simple. If you found out all the functions, what you need to simply do is just integrate them with limits 0 to 2. The first function, which is 6t plus 2t squared. Then the second function, which is 14t minus 8. The limits are 2 to 4. And then the third function from 4 to 16. If you integrate all of these correctly, you should end up with your correct answer. I just want to check if I solved the first part correctly since I didn't check the answers, T5 and T11. Okay. Okay. Integrating them quickly. I have the limits 0 to 2, 2 to 4, that gives me 52 over 3. That gives me 68. Point 666 95. Oh, so something. Oh, it just said it when it's decelerating. Oh my God, I've done this incorrectly. That's the total distance traveled. I didn't see the question properly. So when is it decelerating from 8 to 16. So that's all you had to do. I also calculated that incorrectly. From 0 to 4 over 3. That should be fine. Okay, that's the end of this exam.